Okay, we can go live. Okay, hello everyone. So this is week 12 discussion about this fiber optic communication technology course. Uh, so this is officially supposed to be the last week of the course, and exam, if I have read correctly, is on Saturday, 28 October, which is the Saturday next week. So I hope everyone has prepared. We are still working on the transcripts for the last few weeks. So whatever gets done, we will keep uploading and we'll notify you by this weekend, we hope. Uh, as you can hear from my voice, I've got a cold in Chennai, which is hilarious. But uh, before starting our usual recap, I wanted to make a couple of announcements. So this is not the final live discussion. Madam wants to meet you people, and we will try to have another live discussion where ma'am will be present, and she basically wants to talk about this uh, project that we have started with IIT Madras as the coordinating entity. So just like you have heard about this 5G testbed project, which is trying to set up and I mean, which has already set up a standards testing uh, test bed where we have indigenously developed all of the components of a 5G network. A similar functionality we want to also establish for optical communications, which doesn't have these clear distinctions like 4G, 5G, 6G, that kind. But uh, as the capacity in mobile networks increases, we also need more capacity in the backbone network, which is the optical network. So we are setting up this project. This has been sanctioned this year only, and the goal is to make a complete testbed where different industry or some component manufacturer, anyone can come and test out their components. All of the facilities needed for testing and all, we wish to provide. So regarding that, we also want people to learn about these technologies. So if you do well in the course, we basically want you to come meet us, and if possible, come work with us. Madam has said that if you do well in the course, you're free to apply to work with us as interns or project staff and all. And so expect another announcement, and we will meet either the same slot on next Tuesday, or probably, I mean, ma'am's calendar is looking packed on Tuesday, so it's more likely to be Monday at the same time slot. So I hope people join that meeting. I hope everyone joins in the Zoom meeting. I see some people view it in YouTube without interacting, but I mean, next week Madam is coming, so it will be nicer if you join the Zoom meeting itself instead of watching it later on. Okay, then we will move on to this content. So this is a brief recap. So there weren't any big concepts discussed this week. We were talking about the uh, all of the protocols and all that are required for uh, your physical layer network to work. So if you're sending an email to another person, of course you are using uh, an optical fiber as the physical layer, but how does your email application translate it to your uh, laser on and laser off the physical signals? So how to translate that is governed by these standards, and we started talking about these optical networking concepts to tie up what we have discussed about the physical layer, how it fits into the uh, existing networking concepts. So we started our discussion with this network structure, how this global network is connected to your metro network, how that is in turn getting connected to your uh, mobile phone network and all. So we started with a brief discussion of this network structure and what we require from optical networks, and how a network gets established between 2 points that wish to communicate between uh, the 2 points. And because there are vast number of players that are required to make all this possible, so computer scientists will be working on this higher layers. Then you optical engineers will be working at the physical layer, uh, and uh, network management will use some other standardization. So, like for everyone to work uh, with each other, you need standardization. So one standard model is this open standardized model. You might have seen it in the context of uh, networking in computer science. So here we are talking about uh, optical systems, which is varying from the standard OSI model slightly because of the properties of the optical network. Because optical fiber can support a large capacity, so some modifications are suitable for us. So this physical layer we talk, where we're sending bits, then these are the standard OSI model uh, layers. So this is the lowest layer, layer one. Then physical layer transmits bits. Then data link layer basically translates what is coming from the network layer into what are the exact bits that are going to be sent. So physical layer, data link layer, network layer, and transport layer, and this session presentation and application is happening on your client's PC. You can take in optical systems, like in physical layer, we are sending bits, which is basically everything you learned in this course. This encompasses this fiber infrastructure, and on top of it, there is one optical layer. Then in data link layer, we talk about frames and which bits are getting sent. Some bits will be your uh, data, some bits will inform about your channel, information about that data. So here we have, during the videos, you have seen the frame structure for some of the standards, which will require some header, then your data packet, and some trailer. In our specific examples, like implemented trailers. So here in data link layer, we uh, divert from the OSI model and use these two standards, uh, SONET and SDH, which are interoperable. And there are like standards like how much data you're transmitting. There are different structure where you define how many preamble bits you are sending, how many data bits you are sending, and we saw a frame structure in detail, like the base frame structure, which you see a table with rows and columns. We are just sending them row by row. They will get serialized and sent. So there you've seen the structure, and then for this is for the base data rate. If you want to increase the data rate, yeah, you'll be multiplying everything by some factor, and you will have, for example, uh, uh, 4 times the bits about the metadata, and you will also have 4 times the data in the same 125 microsecond duration. These standards are circuit switch, where you will establish a connection between two nodes and then do all of your sending. One competing standard is IP, which is Internet Protocol. It will tell what are the destinations, and you can think like it is not uh, a stable connection between two nodes. You can think that that packet finds its way to the destination, and it is allowed to take any route to reach the destination. Uh, then we talk about example topologies, how different nodes can be connected. Uh, so we'll be using different kinds of connections for access network, which is connecting to your users, the metro network, wide area network, and global network. So how much data everything is carrying, and how many different connections are getting made. So in access network, there is the most amount of fiber laid because most amount of users are there, but not each user is using large amounts of data. So we talked about different network topologies that are possible. So the simplest case is just point-to-point link, like two computers are there, or like two terminals are there. You just connect it using one fiber. Uh, then it could be a shared bus where all of the users are getting connected to that bus. Then uh, examples of star network, then ring, dual ring, and uh, mesh where every node is connected to every other node, and a tree network where we mentioned that like data centers are usually looking like a tree network. Then we considered one link design example, which is probably the most similar to what is mostly being asked in this week's assignment. Uh, there aren't any big concepts. You just have to consider how power is getting lost at each coupler, and you'll be using uh, a number of couplers to make sure that your power reaches to the transmitter, your power reaches to the receiver. Then we talked briefly in one video about network protection, how we have to ensure that the optical network works for 99.999% of the time, because everything else, your mobile network and uh, all of your users are depending on the optical network to work. So you have to promise them uh, this much reliability, and to enable that reliability, you have to spend more money and lay more fiber, and make sure that your even if your fiber gets cut, you don't result in a failure of communication. So from the moment you detect a problem, you have 60 milliseconds to connect that failure according to this uh, SDH or SONET standard rules. In this context, we also talked about, we briefly mentioned this device called OTDR, Optical Time Domain Reflectometer, which basically sends a short pulse of light, and uh, because of the fiber, there will be Rayleigh scattering, and from each point there will be scattered light, which will travel back along the fiber, which will be very low power, but we will try to detect that power. And because we have set pulse light, we can correlate the time it takes for light to travel, and we can exactly say that, okay, this backscattered light is coming from this much distance. You can exactly say that along this fiber nothing happens for this much length, and at 1 kilometer there is some kind of loss, or at 1 kilometer there is a strong reflection, which basically specifies that there has been some kind of cut. So some Fresnel reflection is happening. So this is a common equipment that is used to detect where the fiber has been cut, or where some problem is there. Maybe some connection is lossy, maybe some section of the fiber is bad. So this device OTDR is useful for that. Then we talked about this access networks and passive optical networks, which are not using amplifiers. This is basically last mile connection to your home or your users, where we encounter these two terms: optical line terminal, your service provider's office, and optical network unit, which is your house. And we talked about different passive optical network configurations, because the fiber can support much more bandwidth than what a single user will use. So we can use this time division multiplexing, or maybe if all of the users are using high amounts of data, you can also do wavelength division multiplexing, where you're sending data in different colors. Then we briefly looked at a table on this passive optical network standards. The most common these days is this gigabit PON. With that, we closed our discussion on passive optical networks. Then we talked about this data center optical interconnects, where you want high amounts of data to flow between servers. What kind of possibilities are there? And finally, we close the course with what are the requirements for wireless networks. So your cell phone towers will communicate among each other and to a base processing server that communication will happen over optical fibers. And you can see that from the portal example that this, even for 3G or 4G communication, you need large amounts of bandwidth. And as the wireless networks evolve, there will be more and more demand on the backbone, which is the optical network. So you need optical network to also improve its performance and improve its capacity if you wish to continue improving your wireless networks. With that, we finish the course. As far as the assignment goes, it is mostly asking about this passive optical networks, how much power you're losing, But in the middle, from question 7 to 11 are all like toy questions, where you're being asked to find the geometries and find distances between different nodes. So uh, don't take that part too seriously. Just those 4 questions are just for fun. And I hope there aren't any doubts uh, from this week's content, because I mean, the forum is like quite silent. And there aren't any big concepts, but just a lot of information was provided this week. So make notes. We will also try to provide the transcripts. There aren't any formulas. If there are any doubts, we can talk. Am I audible? Is the audio dropping? I hope it's not.
No, sir, you are audible properly.
Okay, thanks. Okay, YouTube is also silent. Just the announcements are just this. There will be another live discussion next week, uh, probably Monday or Tuesday, same slot, where ma'am will be present. And she will talk about this new project for which we would like you to learn this, because our industry also wants workers with the knowledge that is used for this. And exam is on uh, next Saturday, as in next week's Saturday. So I hope everyone prepares well, and if you perform well, we want you to work with us, of course.
Sir, is it possible to provide any demo question paper of the previous year for help?
That was set up by ma'am. I don't have access to the question. I can ask around.
Only demo questions. How to answer? What type of questions?
Questions will be based on your assignment questions. Like, it won't be more complicated than that. This will also be graded by computer itself. So it will be computerized test. So questions will be similar to your assignment questions.
Okay, sir.
I'll try to find if you can be given some questions.
Okay, sir.
But like, we are not setting the question paper. It's all given by ma'am. Probably the question paper was probably set before we even started the course. So okay, I'll talk about it. And admit card and all, I don't have information. That's all handled by NPTEL. Us 3 years have no information about what is being organized.
Okay, sir.
On YouTube side also, I don't see any questions. Okay, then if there are no doubts, we can close. Feel free to drop any questions.
Sir, another question: whether the center will be declared before the exam, na? Before 1 week of the exam?
Yeah, it should be mentioned in your admit card and all.
Okay. Thank you, sir.
Yeah, like, you won't be kept in the dark.
Okay.
And feel free to use the forums. Like, I know there have been a few questions pending that I'll also post within this week. And For this week's questions, like question number 7 to 11 are the only like weird questions. Have fun, like don't worry too much. It's just asking you to find some geometry. Okay, we will close if there are no questions.
Thank you, sir.
And hope to see you again in the meeting where ma'am will be there. Okay, we can close.